Hi, sir.
Hello. Yeah, something told me like it's too hard recent weeks, especially when we discuss the senior questions. It's too hard. Did you try the question? Like,
然后我试了，然后我感觉好像有一块做错了，但是真忘了。
okay. Yeah,
讲一
this
下，
one.
能讲一下吗？这
Yeah,
个
we can.
谢谢。
你在这个群里吗？
我好
你在这个
像
微信群里吗？
没有吧，我妈在。
哦，对哦，所以你妈把题转给你了是吧？Okay. Yeah, this is a hard one, huh? Okay. But yeah, we can check. We can check it.
啊？
We need to check a question from last week. I know it's for senior student, like for year 12 and above. But some students hope we can discuss, because the knowledge we need is actually year 11 or year 10. For example, we can do some pre stuff. Before we can work out the question, you need to understand this. How can you find the distance between 2 points? For example, between A, 1, 2, B, 4, 6. How you find the distance here? Okay, let's sketch it. A is 1, 2. This is A. B is 4, 6. Yo, 4, 6. This is B. How we find the distance? Like how we find the length here? You can really check this way and this way separately. Horizontally, Vincent, horizontally, how many units?
4.
This is 1. This is 4. So how about here? How many units? How long is this part?
Oh, 3, sorry.
Oh yeah, 3. Ryan, how about this piece? This piece just 4. This piece just 4. So the distance is Pythagoras. 5. You guys understand this idea, how we find the distance? Yeah, first we try to do some knowledge so we ready or prepared for the challenging question. So how we find the distance? We just use Pythagoras. If you rewrite this one as symbols, algebra way, like a formula way we can check this way. For example, if A, we have two values, one for X, one for Y. So I use X1, Y1. B, X2, Y2. And this part is X2 minus X1. The vertical part is Y2 minus Y1. So the distance from here is a square root. X2 minus X1 squared plus Y2 minus Y1 squared. Or you can say from A to B, you have change in X and change in Y. Or sometimes we say rise or run. Or sometimes we say here is rise, here is a run. So that's for distance. For distance. So you just use run square plus rise square and the square root. Or you can say the change in X squared plus change in Y squared and then square root. So Pythagoras. To work out this distance, we use Pythagoras. Okay, let's check several questions. One. We have A equals -1, 1, B, 3, maybe 4, even more. 13. What's the distance between A, B? Guys, work it out and message me. Work it out and message me. So the second one. A. That's little a. Oh, we are doing distance. If you say rise over run, that will be the gradient. In this question, if you think about the gradient, that will be 4/3. But now we are checking distance. Yeah, gradient is rise over run. Okay. Yes, it's kind of like the rise square plus run square, and then square root. It's kind of here. The run square plus the rise square and the square root. Oh, the other one, B. Point B equals A plus 3, B plus 4. You know, what's the distance between AB? Sometimes distance AB, we just put two lines here. Distance AB. Guys, try to message me. Message me. Good. You guys so good. Oh, that's the distance. That's the distance. Well, another one, 3. A equals 1, 1. B equals 2, 2. What's the distance? What's the distance? Okay, we try to work out distance. Yeah, Teresa, message me your answer on. Justin message me the answer. Good. So that's how we work out the distance. You can use the distance idea to do something here, Okay, try to work out this first. This question later you got here 4 minus -1. We use the change. 13 minus 1, they all squared. So square root of 5 squared plus 12 squared, root of 169 give you 13. And the second one, from A to A plus 3, the change just 3. From B to B plus 4, the change is 4, so which is 5. How about part 3? Part 3. Oh yeah, it's just the change 1, so just root 2, just root 2. How we use this distance to prove something in geometry? For example, guys, number 4. We have 3 points, A, B, C. We got 3 points. A is 3, 7. B is 5, 2. Oh. Yeah, it's not in scale, not in scale. Here, -2. Now, prove triangle ABC is right angle triangle. Number 4, right angle triangle. Okay, right angle triangle. Yeah, we're checking the hard question. The hard question should be around here. This one. Oh, expired. Expired. This one expired. Oh, they all expired. Oh, okay. Yeah, later we're back to worksheet so we can find the question. How we prove it? If you prove right angle triangle, you can prove 90 degree, or you can prove the distance or the length square using Pythagoras. For example, you need to calculate what's AB and what's AB squared? What's BC? AC. What's AC squared? BC. What's BC squared? If you have A squared plus B squared, A equals C squared, we can say it's a right angle triangle. We have here. Yo. AB. Our formula AB. Change in X. From A to B, the change in X is 2. The change in Y is 5. Oh, you can say -5, but if we square, it's okay. So this is 29. AC. The change in X, 3 and 2, the -2, the change is 5. 5 and 7, the change is 2. What? Still 29. Oh, okay. Still 29. That's an isosceles triangle, eh? We know isosceles triangle now. Now BC. This changes 7. The other change is 3, which is 58. So we have AB square AC square equals BC square. Therefore, right angle triangle. And by the way, it's an isosceles right angle triangle. Okay, isosceles right angle triangle. Yeah, check if you understand the idea. If you understand the idea. Okay, that's number 4. Okay, number 5. Here. Number 5, like, you can also determine something. It's a check. We still use some same number, 3, 7. That's A. B. 5, 1. C. -2, 5. Now, this triangle, is this triangle ABC? Right angle triangle, acute angle triangle, or obtuse angle triangle? Obtuse like this way, look like this way. Which one? Which one? Yeah, this triangle, what type of triangle is this? Okay, what type of triangle is this? Again, you just calculate some distance. Yeah, from now on, like we need to prepare some knowledge when we try hard one on. Not like just start from the question. That may people or student, everybody feel too much challenge. AB change in